So far is we actually did a proof, didn't we? We proved theorem 3.4, and you can kind of look over that. We were given angle 3 is congruent to angle 4, given that. And then our goal was to show that A and B are parallel. And the only way that we know how to do that is with corresponding angles, at least with using a postulate. We're proving one of our theorems. And so we used vertical angles congruence theorem, and then we were able to do the transitive property, and then we were able to say that the lines were parallel by corresponding angles converse. So that was a proof of one of the theorems that we did on the opposite page. Example 3, it looks like we did that together already. Can anybody care to tell me why it's AD and BC that are parallel and not the other ones? Alternate what? Interior angles. Could that also work for AB and DC?
No, because they're not defined as a separate.
Okay, so this transversal and the angles we know about only touch this side and this side, right? Do you guys see that? Okay. Well, let me go ahead and write that down real quick. Alternate interior angles. What about part B? Which lines?
ABCD or ABDC.
AB and what'd you say?
DC.
DC. I concur. I guess it says which lines, so we'll go ahead and write them as lines. What's our justification?
Vertical angles concur. Vertical angles. Alternate interior angles. That one.
Alternate interior angles?
Yeah, I got you.
Oh, and I guess it's actually alternate interior angles what?
Converse.
Converse. Yeah, I should probably add that. Converse.
Yeah.
That's what we do when they're not parallel.
Yeah, because we're actually showing them parallel rather than starting with them parallel. Now C looks a little bit funny. Do you guys see how these arc marks go all the way across these two angles?
Yeah.
Okay. So what do you guys think? Which lines are FD and CA? FD and CA. Is everybody in agreement?
Yes.
Well, I suppose if we're able to say that they're parallel, we should probably have a reason for saying that. What's your reason?
Corresponding angles converse.
Yeah, corresponding angles converse. Yep, so these are in the same location as these. And some, don't be afraid to like draw a little bit extra on there. And it helps you to see, oh yeah, those are in the same place.
I'm confused. Why not ED and BA?
ED and BA. Well, the reason why is because this arc mark is not stopping at each angle. It's passing through. And so you actually just know that these big angles are the same. Turns out ED could be, adjusted a little bit off. And so the overall angle is the same, but those individual angles are different.
Okay.
Definitely visually it looks like it though, doesn't it?
Yeah.
All right, let's see here. What do we know on part D? DAB and angle 3. So what I'm going to kind of do is I'm going to mark, kind of do that big arc mark again. And then I'm not going to show that it's congruent to angle 3. I'm just going to show that we're talking about angle 3. So I'm going to do a double arc mark there. So I'm not saying that they're the same. I'm just saying that we know information about those, right? Well, if we know that the two angles I marked are supplementary, which two lines have to be parallel? ED and BA, what do you guys think? Mr. Atkins speaking. Yeah, just a second. Ryan, it's for you. Question, Will.
So like it says measure DAB, but for a DAB, so like I see how like you like did that, but would we not connect it all the way over to D for the arc mark?
Oh, well, I mean, you could, but
It just gets
it's just, the arc is just the measuring of the opening. So we just gotta go from side to side.
Okay.
Yep, yep.
Okay, is that, can I get that?
So I think you guys were right. What would you say, ED? Oh my God, I got you. I got you.
What the heck?
It's okay, Ryan.
That is smart fingers.
Yeah. They're tough.
Ryan's trying to work his phone, guys.
Hey, it's better that the teachers in the middle school kept dropping them in the trash can.
What, really?
Because it was the
Oh.
phones, because it was,
That was like a
receiver was a
thing?
little different,
Yeah.
so they would think it would be connected, and then they would just drop into the trash
Right in
can.
this trash can. Maybe I need to move my trash can. All right, well, so ED and what again? I'm sorry, BA. And what's our justification?
Consecutive interior angles.
Yeah, consecutive interior
They didn't.
angles, converse. Okay, looks like we got one more proof to look at. One more proof. We are given some stuff. We're given line A is parallel to line B. How can you represent that in your drawing?
Arrows.
Arrows, yep, line A and line B. And we also know that angle 1 is congruent to angle 3.
Angle 1 is also congruent to angle 2.
1, 3. Say what now? Sorry.
1 is congruent to 2 because of alternate exterior.
Okay, so, wait, before I write that down, do we have kind of a game plan here?
No.
That should actually
We can
be
do
our-
alternate
that could be
exterior,
our second
and
option.
since 2 and 3 are alternate interior, we could use the transitive and remove 2 for 1,
Okay,
if that makes
Would
sense.
that prove?
okay, I think so.
Or-
Yeah, so I think do alternate exterior angles to get this one, and then we'd have them all the same, right? But our goal, I think, is we'd have to write out that 2 is congruent to 3, because then wouldn't that prove that C and D are parallel?
Yeah, with the.
By which one?
Well, to do that, it would be
angles, converse.
Alternate interior angles, converse? Yeah, okay, so yeah, I think we can get there. So I agree with our first step. Let's say that angle 1 is congruent to angle 2. I'll go ahead and mark it. And what was our reason again?
Alternate exterior.
Alternate exterior angles. Congruent, oh yeah, you can write theorem. There we go, that sounds a little better, doesn't it? Alternate exterior angles theorem. And then from there,
Does it have
since,
to be theorem?
say what?
Does it have to be theorem? Yeah, because in the thing, it just says
Yeah,
consecutive.
it does
interior
actually.
angles.
I don't count off for that, but, it is a theorem, yeah.
Okay.
It turns out the postulates are only the corresponding angles ones. All right, so I'm actually gonna rewrite this real quick because I basically want 2 to be congruent to 3, right? And because I have these written as congruent and not equals, I'm gonna have to use the transitive property, and right now, I don't think they link up exactly right. So I'm just gonna, I wrote in ink unfortunately, but I'm gonna say angle 2 is congruent to angle 1. And the reason why is because now, can't I say that angle 2 is congruent to angle 3?
Yeah.
By what reasoning?
The transitive.
Property of
Yeah, the transitive
B or
property
C.
of congruence. And now, we can say, because 2 is congruent to 3, we can say that line C is parallel to line D by the alternate Interior angles converse.
What's the difference between the converse and the theorems?
Well, so the theorem is used when you know lines are parallel and you're making a statement about the angles. Do you see that? But now we're making a statement about the lines being parallel, and so we're going backwards. We're going backwards.
I see.
Yep. What do you guys think?
Pretty good.
Pretty good. All right. Our practice is something. I think I got it on Canvas already. So let me find that for you.
Mr. Arkin?
Yeah.
I think on letter C of example number 3, we could prove that FD and CA are congruent.
FD and CA.
Yeah.
Oh yeah.
Because if you just ignore line ED and BA, then those two are congruent, and then because of supplementary angles, then that would make 4 and 5 congruent.
Let's see. So 4
And
and
maybe
5.
corresponding angles.
Because if angle 1 and 3 add up to the same thing as 2 and 6, that means that 4 and 5 are congruent,
Yeah, but how do you know that?
or supplementary